Hello, my name is Impact.
Here you can find every conceivable type of robot and computer. Some are clever, a few less so, and one or two purport to be intelligent. But however fantastic we may think they are, however clever, they're robots, just robots. But could any of them think, intelligently work out a problem or react to data and experience? I tried to find a few of them, and they do exist. Machines have been able to see for a long time, or rather capture what we see. Makes no decisions. I point it and... But how about a machine that interprets what it sees? Well, I'm being watched by one now. This one follows me as I walk around the room. But it's still a prototype, so it's not too hard to trick it. This computerized visual responder has a program based on the eye of the common housefly. It can recognize form and shape. If it sees any change in its data, like movement, it can react.
So the system will pick me up and follow me around as I move around here.
But the sheer number of commands and the size of the computer needed is more a tribute to our own brain power, and the flies too.
Many years ago, it was thought of being a one-year project or five-year project, and we're still at it 15 or 20 years later. Laymen are always amazed at how difficult it is to be able to do something with a computer, a very powerful computer, that somebody like my 3-month-old son can do very well.
Or take the case of this so-called intelligent industrial grab.
First, recognize the part.
Its job is to recognize an object, work out where it is spatially compared with other objects, how it's going to grab hold of it without bumping into things or knocking anything over, and then extract it. Again, it's a very complex task, and to do it, it needs a laser to build up an image of where the offending object is. This produces a shape image in its memory, with which it can do some calculations. In this case, they've abandoned the human brain as a model for design. It would be just too complex.
Here we're learning something about manipulation and about vision. Now, it doesn't directly transfer to something that we can know about humans, but it does allow us to know something about what questions we should be asking. How does a human take into account the obstacles? How does a human plan its motions? And those are questions that wouldn't occur to us if we hadn't seen how difficult it is, how overwhelming the task is to actually get a robot to do it.
But the one I liked best of all was the reading machine, developed at the Johns Hopkins University by Dr. Sosnowski. What's it doing?
It's looking at the letters and it's trying to figure out what the sound is. And it's picking up right now the difference between a consonant and a vowel.
This is a recording of the first step. Before it can read, it has to teach itself how to speak. Text from a book has to be translated into phonemes, or phonetic sounds that can then be correlated with written words. The machine takes time to learn its phonemes. After a few hours, it sounds a little more proficient.
I know what it's trying to say. But, they say that parents can understand their child better than anyone else.
Leave it overnight, and the following morning, it sounds just like an 8-year-old child reading.
She gets low fevers and stuff, and then she can't breathe very well and she gets sick. That's why we can't run. I like to go to my grandmother's house.
It just goes to show that we are indeed well served by our own brain. But the days of world domination by automatons is still in the realm of Star Wars. But what of the future? Where will brain research take us into the 90s?
I would be very happy if we and other people in the field offer the understanding of some form of behavior like manic depression or schizophrenia.
Well, I look immediately at the greatest needs, which would be in brains which have been damaged, and in the spinal cord, which has been damaged. And so, if parts are cut, to find ways to bridge those cuts. And I think we will learn shortly how to use the glial cells as bridges, perhaps, on artificial devices.
I think we should understand that we are in the new golden age of biology. We are in the era of recombinant DNA technology. And the power that this will give us to control biological processes will be absolutely enormous.
And as we approach the turn of the century, it's quite possible we'll find treatments for drug addiction, even some types of criminal behavior. But we'll never unravel all those millions of billions of interconnections, those myriads of mysterious pathways, those dendrites and synapses that reason and calculate, love and hate, perceive and persecute. Megabytes and gigabytes will never begin to approach the power of the neuron.